The combined gas law assesses the characteristics of a constant amount of gas when the pressure value and/or temperature is allowed to change. The combined gas law is made up of three other gas laws.
The first gas law is the Boyle's law. When using the Boyle's law, the temperature remains the same and the volume is inversely proportional to its absolute pressure.
The second gas law is the Gay-Lussac's law, where the volume remains the same but the pressure is directly proportional to its absolute temperature.
The last gas law is the Charles law, which describes how gases tend to expand when heated. The pressure remains constant and the volume is directly proportional to the absolute temp.
If I initially have a gas at a pressure of 12 atm, a volume of 23 liters, and a temperature of 200 K, and then I raise the pressure to 14 atm and increase the temperature to 300 K, what is the new volume of the gas?
Okay, so what you do here is we are using the combined gas law. So what you do is on one side of the equation you have 23 liters multiplied by 12 atm, and then you put that all over 200 Kelvin. And then on the other side of the equation you have 14 atm times V for volume all over 300 Kelvin. So then what we do from there is we cross multiply, and then we get that 82,800 equals 2,800 times V for volume. So what we do here is we divide the 82,800 by the 2,800 to isolate V. And then after that, we get 30 liters is the volume.
A container holds 50 milliliters of nitrogen at 25 degrees Celsius and a pressure of 736 mmHg. What will be its volume if the temperature increases by 35 degrees Celsius?
Okay, so for this problem, we are using Charles's law, as shown on the paper. So first, before we do anything, we have to convert the temperature to Kelvin instead of Celsius. So we take the 25 degrees Celsius, and then we add 273 to make it Kelvin. And then with the other temperature, we have to add 35 degrees Celsius to the 25 degrees Celsius because that's what the problem stated, and then we add the 273. So after we do that, we get the 50 milliliters over 298 Kelvin, and then V for volume over 333 Kelvin. So from there, again, we have to cross multiply as usual, and then we get that 16,650 is equal to 298 times V for volume. So then what we do from here is we just divide by the 298, and then we get that the volume is 55.9 milliliters of nitrogen dose.
A 50 milliliter soap bubble is blown at standard pressure. When a thunderstorm passes later in the day, the pressure becomes 700 mmHg. What is its new volume?
Okay, so for this problem, we are using Boyle's law. So what we have to do is we put the 50 milliliters over the 760 mmHg, and then on the other side, we put V over 700 mmHg. So then from here, as usual, we cross multiply, and then we get that 35,000 equals 760 V. So then we just divide by 760 on both sides, and then we get our volume of 46.05 milliliters.
Determine the pressure change when a constant volume of gas at 1 atm is heated from 20 degrees Celsius to 30 degrees Celsius.
Okay, so for this problem, we have to use the Gay-Lussac's law, I think. So we have to convert the temperature first off. So we take both the 20 degrees Celsius and the 30 degrees Celsius, and we just add 273 to both of them to get our temperatures. So we put the 1 atmosphere over the 20 degrees Celsius plus the Kelvin, so it's now 293 Kelvin. And then we put pressure over the 303 Kelvin from the 30 degrees Celsius. So from there, we cross multiply, and then we get 303 equals 293 P, and then from there we just divide by 293, and then we get that P equals 1.03 atmosphere.